Hey everyone, today we are going to talk about inheritance in object oriented programming. So, this video is second in our object oriented programming discussion. If you have not watched the first recording yet, I would recommend that you go through the first video before checking out this one because this will build up on the first video. Now, let's talk about inheritance. And to understand inheritance, let me take a very simple example. So, imagine a parent and a kid. So, as you all know, a kid would inherit many of the attributes and characteristics and the behaviors and traits of parent. So maybe we have a parent and we have the child. So many of the attributes, characteristics, and trait would be inherited as it is by the child. So maybe the child has the same eye color, hair color, or maybe temperament as the parent. So it will inherit those properties as it is. So if we have a parent class, let's create a parent class and I'll define two methods here. The first one is the eye color. This is simply returning black. Another is hobbies. This returns karting. So now let's say we want to also go ahead and create a child class. But we know that child inherits a lot of properties and attributes from the parent class. It has similar traits as parent. So instead of creating a brand new child class, we can inherit from the parent class. How does the child class inherit from the parent class? The name of the class, and in the parenthesis, you would give the name of the parent class. So let's just put pass here. Now let's go ahead and create an object of the child class. So I'll say C1 child. Now this, if you check the type of C1, you can see it is an object of the child class here. Now if I do C1 dot eye color, it gives me black. But we don't have eye color function in the child class. So why is it returning me black? Because I'm inheriting from the parent class and there's a function called iColor in the parent class. So this gets executed, it returns black value. That means these methods or behaviors or traits we are inheriting from the parent class. But not all the traits would be same. Obviously, a child is an individual. He would not be a clone of the parent. He would inherit a lot of qualities and features and attributes, but he would not be an exact copy. That means some of the things we need to override as well. So maybe the child has different hobbies than parent. So right now, if we check the hobby of the child, it is gardening, but it is not gardening. Let's say it's reading. So how do we override the behavior of the parent class? We can create the function with the same name, hobbies, in the child class. Then from here, we can return reading. So now this is returning us reading. We can inherit as it is or we can override the existing. Now let's say the child has interest in musical instruments, so maybe the child plays guitar, but the parent or the mother or the father never learned how to play any musical instrument. So we can also have exclusive methods in the exclusive behaviors or traits or methods in parent class, in child class, sorry. So let's say we have a method here called musical instrument. music, and this returns guitar. So while the parent class doesn't have any method called musical instrument, the child class has the method. So let's just try this out as well. So we can say C1 dot musical instrument. We have it's returning guitar here. So that means the child can inherit as it is from the parent class. It can also override some of the features or traits of the parent class. And we can have some exclusive methods defined in the child class as well, which are not present in the parent class. So, very much inspired by the real world scenarios. So, now that you understand what inheritance is, let's apply it to the bank account problem. So, we created this bank account class in the last video. This bank account class has these attributes: account holder, the PAN card, the balance, the transaction history. And there were two methods also in here, the deposit and the withdraw. Now, let's say we want to create different accounts. Maybe we want to also create savings account, current. Maybe this bank offers multiple accounts, multiple types of accounts. So these different accounts will share common characteristics like account holder name, the balance, the deposit, and the withdraw feature with this bank account class. But different accounts will also have their own rules. Like the saving account may have an interest rate. The current account may allow unlimited withdrawals. Account, fixed deposit account will have a lock-in period. So we can either write separate classes from scratch, or we can inherit from the base class, which would be our bank account class in this case, and modify the individual classes accordingly then. So let's try it out. So let's go ahead and create a savings account class. And this class inherits from the base class, from this class, the bank account class. For it to inherit, we have to put in parenthesis the name of the class, colon. And let's say the withdraw and the deposit functions remain as it is. So we are inheriting them as it is. You're okay with the init function also. These are the attributes that we want to define or set while creating an object of the saving account class. Now we can have another class attribute called interest rate. I'll set it to 7. And then we can create a function to apply the interest rate. So maybe this is annual interest, simple interest that we want to apply. Self is always the first argument. And we can calculate the interest. That is nothing but the self dot balance multiplied by self dot interest rate divided by 100. And then we have to update the balance also. Let's say every year end, we go ahead and update the balance and add the interest to it. It is giving us name error. Bank accounts, I need to run this. Now this is fine. Now let's go ahead and create an object of this savings account. So if I run it as it is, do you think this will run fine? No, it will give us error. Why? The error says that missing 3 required positional argument, name, PAN card, and balance. Why is it giving us that error? Because it is inheriting this init function from the bank account class. So when we create an object of the saving account class, you know that automatically the constructor function or the init function gets called. And the init function takes three arguments. So we have to provide those values, the name, the PAN card, and the balance. RN is the name, random value for the PAN card, balance is 50. Now S1 dot balance, if we check, that's 50. Now let's go ahead and call this apply, or maybe first let's deposit some money. So $100. Now if you check the balance again, S1 dot balance, it's 150. 50 plus 100 is 150. Let's call this apply interest. Let's say it's already a year and now it's time to reap some benefit of depositing our money in the bank. So S1 dot apply interest doesn't take any input. And now if I check the balance, it's 160.5 because I've got that interest. 10.5 is my interest. So here we have added, although the saving account, all the other features remain same, the deposit, the withdraw, even the attributes are same, but we have this additional feature where we are giving interest to our customers who are depositing their money in the savings account. Let's say for the deposit account, we want to remove the withdrawal limit. So there's no withdrawal limit. So that means this one, there is no withdrawal limit. That means we need to change this function. We need to override the function. In this case, in the saving account case, we have added a new function. Now we want to create a currents account and we want to override this withdraw function. So how to do that? We can just say class current account. The name of our base class is bank account. And then we can just to override this function because there's no limit to withdraw. We just copy paste it and change it, modify it. So this has to go away. Yep. So this is fine. So now let's run it. Let's create an object of this current account class. It's capital C. Okay, and we have to again pass the name, the PAN card, the balance. Just copy paste from here. And now if I try to withdraw 100, which will take my balance to negative, it will let me do that. Why? Because in this current account withdraw function, I'm not checking if the withdrawal amount is less than the bank balance or not. My updated balance is minus 50. So now if you check the balance, it's minus 50. But the deposit works as it is. See 100. This works perfectly fine. What if I try to call this apply interest? Will that work? No. Why? Because what we are doing here, we are taking our base class, the parent class, and we have the saving account is also inheriting from this parent class, and also the current account is inheriting. But these two are not related, right? It's not that the current account is inheriting from the savings. So when you try to run this apply interest, it will obviously give you an error. If you say C1 dot apply interest, it will give you the attribute error which is expected. So now let's work with our third account type, which is the fixed deposit account. So fixed deposit account basically has a lock-in period. Now let's say I want to have the lock-in period as one of the instance attribute. So for a fixed deposit account, the lock-in period would also be an attribute that with this particular account, how much is the lock-in period. So that would be an attribute of that account. Only for the fixed deposit account, I want this additional attribute. So how can I do it? Now let's see that. So let's first create a class for the fixed deposit account and it will inherit from the bank account class. Now because I want to override this function, right? I want to override because I want to add one more attribute here. So what I can do is I can just copy paste it right here. Majority of the attributes remain as it is, right? We only want to add another attribute. So either we can do it like this. Just say self dot lock-in. Then we can set it to a value. Or we can take the lock-in period as an input from the user as well, like this. Whatever the user inputs, that we can assign it to this variable lock-in here. So this is fine, this will work. But a better way to do it is by basically calling the parent constructor. So first, what we want to do is we want to call the init method of the parent class, and then we want to assign the value to the new attribute from here. So for that, we can use super keyword. I can just get rid of all of this and I can say super, this is a function, so parenthesis dot in it underscore underscore. Then we can give the name, whatever name, PAN card, balance we are getting as an input, we can provide it to this init function and then set the value for lock-in here. So what are we doing here exactly? So this super basically is used to call a function which is written in the parent class. So what are we doing here? We are creating this init function. So we are overriding the init function of the parent class. And then from inside this init function, we are calling the init function or method of the parent class. How do we call the init function or the method of the parent class? By using this super function. So super dot init method name and the arguments that this function takes. And then we are setting the value of this lock-in variable because the lock-in variable value is not getting set here in the parent class. So we are doing it here inside this init function. So first, we are calling the init function of the parent class. That's what this line is doing. And then we are setting the value for the lock-in attribute. Let's just go ahead and define another function here. And we want to check when the fixed deposit matures. After the lock-in period, the fixed deposit will mature and you can withdraw the money. Let's say there's a function to check the maturity. The customer wants to check when his fixed deposit will mature. He can call this function. Self is always the first argument and return fixed deposit matures in self dot lock-in months. That's it. Let's create an object of this fixed deposit account class. Again, not three this time. We have to pass name, PAN card, balance, and lock-in as well. If we just pass three values, it will give us an error. Let's see. Type error, missing one required positional argument, lock-in. You have to, so that means this init function is overriding the init function in the base class or the parent class. This one takes four arguments. Lock-in period is, let's say, 12 months. And now, if you want to check what is the balance, it's 90. If you want to check maturity, this is this is a function. Fixed deposit matures in 12 months. So why use inheritance? The first one is that with inheritance, you you don't need to rewrite the code for every type of account. It gives better organization, keeps the code structured and clean. And if there are any changes, if tomorrow the bank changes its policies, maybe it also wants to save the Aadhaar card number or any other detail about the customer, maybe their mobile number they want to save. So you can just go ahead and make the changes to the base class and they will apply to all the child classes. So we'll explore the different types of inheritance in the upcoming video. And we'll also talk about polymorphism, which is again one of the properties of object-oriented programming. I hope you enjoyed this video. So that's all for this one, everyone. Thank you for joining in. See you in the next one.